Welcome dear students. Here today we are going to learn the MSc first year CHI-230 course, that is Bioinorganic Chemistry. Okay, we already discussed in this bioinorganic courses, that is the types of the biomolecules, that is protein and non-protein. In that we learn the transport and storage protein. We already discussed on electron carriers, that is iron, sulfur, protein. Only this topic is included in our syllabus, that's why here we learn only this topic. Next is that the metal management, that means the transport and storage of the metal, and here we consider the metal that is the Fe. Okay, that's why here in today we are going to learn, that is ferritin and the transferrin. Ferritin is the iron storage protein and the transferrin is the iron transport protein. And in this topic, that is oxygen management, we already discussed, that is myoglobin and the hemoglobin. Okay, so let's start with our today's topic, that is what? Ferritin and transferrin. Before to learn the what is the ferritin and the transferrin, we must know the importance of the iron in our body. Okay, importance of iron in our body. Iron in daily routine, we require about 10 to 20 mg of the iron. Okay, but whenever we take this amount of the iron from vegetables, fruit, okay, then here from that we absorb, our body absorb only 1 to 2 mg of the Fe per day. That means we has to take 10 to 20 mg of iron, okay, in our body from different vegetables and the fruit. Our body absorb only 1 to 2 mg of the iron per day. Then this amount of the iron is transported by using transferrin. This is a transport ion. This transferrin which transport the iron into different area of our body where the iron is required. First, about 75% of the Fe which is transported by transferrin into the hemoglobin. Okay, where these iron which is binded to the porphyrin ring and the number of amino acids, then they can do their function of what? Oxygen binding. These bind the oxygen from lungs to the different part of our body. Okay, next is what? The iron which can be transported from the transferrin, about 10 to 20%. This 10 to 20% of the iron is transported to the ferritin, where the iron which can be stored, and this ferritin which is present in what? Liver and the heart. Okay, why we has to require, or we has to store this iron into the ferritin? Because in our everyday diet we doesn't take the iron. Okay, that's why whenever it doesn't take the iron from outside, then this ferritin which releases the iron where it required. Next is this 5 to 15% of the iron Fe which is useful for the other processes. Like, which are the other processes? Like this iron which is useful in what? FES cluster. This FES cluster which is useful for what? The transportation and the storage of the electron. Next is this iron also useful for the storage of the oxygen in the form of myoglobin. Myoglobin also bind by using the iron. That means in the different processes we require the iron, which is about what? 5 to 50%. And about we lost 1 to 2 mg of iron per day from what? Desquamation of the epithelia. That means it means desquamation of epithelia, that is a peeling of the skin, or the removal of the outer part of the skin, okay, due to what? The iron loss. This is about the requirement of the iron in our body. Okay, next here we learn that is iron storage protein, that is what? The ferritin. This is the ferritin. Okay, this ferritin is the iron storage protein. This is also called as a hemosiderin. This is mainly present in the human and the higher animal and the plant. This is in human, this is stored in what? Liver, bone marrow, and also the intestinal mucosa and the spleen. Then each protein, here the outer part of this protein, that is called as apoferritin. This apoferritin molecule can combine with about 4,000 atoms of the iron. It combines what? The 4,000 atoms of the iron. Here this apoferritin, which contains the 24 protein units. Let me see. This is what is this ferritin. Okay, here this is the ferritin. Here this is the circular structure of this ferritin, like this manner, and here, and this outer part of this ferritin, that is called as the apoferritin. Okay, this is the coat of the protein, that is called as a apoferritin. Outer part of this ferritin is called as apoferritin. Okay, this apoferritin, and at the center there is a iron core. This is, here, 1 minute, I am going to change the color for understanding. Okay, here this inner part, that is called as a Fe core. This is called as Fe core. Okay, this Fe core which contains the Fe. Okay, this Fe core which contains the Fe. Here each Fe contains the 4,500 of Fe. Okay, here this protein, ferritin protein which contains the 24 units. Okay, and each units of protein. Okay, and each unit contains 175 amino acid. This is very important. This ferritin which contains the 24 protein subunits, and each unit contains 175 amino acids. Okay, here this shell or this apoferritin contains the 8 channels. This contains 8 channel. Okay, these 8 channels which are hydrophilic in nature. These channels are hydrophilic in nature. That means what? These are the water loving compounds. What is the function of this channel? Here this Fe which can be comes inside the ferritin. Okay, and it contains 6 channel which are hydrophobic in nature. These are hydrophobic in nature. How? Why these are the hydrophobic? Hydrophobic means what? Water hating. For what? For leaves the iron from this ferritin unit. From leaves this iron from the ferritin units. Okay. You can see in this. This is the ferritin structure. Here in this ferritin structure, these are the iron core, and here the outer part of this ferritin, this is called as what? Apoferritin. Outer part or outer shell is called as what? Apoferritin. This apoferritin contains what? 24 subunits of the protein, and each subunit contains what? 175 amino acid. 175 amino acids. Okay, and here these ferritin, which are the iron carrying protein, and this protein has a molecular weight 75,000. Okay, and here in this core, iron which is having +2 oxidation state, which oxidized to +3 oxidation state. How it convert into the +3 oxidation state? Here this 2Fe 2 plus, which is reacted with or which is oxidized to oxygen, and it is reacted with the 4 moles of water molecules, and it get converted to the 2 moles of Fe having 3 plus oxidation state and OOH units. Okay, plus removing H2O2 and 4 protons. That means this iron, which is always stored in the form of FeOOH. That means here outer side, this Fe which is present in +2 oxidation state, then it get oxidized with the water and it get converted to the Fe3 plus in form of FeOOH plus H2O2 and the 4 protons. Okay, here for entering the Fe inside the core, there are total 8 channels. 8 channels, and these channels are what? Hydrophilic in nature. Hydrophilic in nature. Why? Because here these are the water loving, and that's why due to the stream of water, this iron which can be entered into the ferritin structure or the iron core. Then for whenever this iron is required, then what happen? For removing this iron from iron core to the outside of the structure, it contains the 6 channel, and these 6 channel are hydrophobic in nature. These are hydrophobic in nature. Hydrophobic, that means water hating compound, and due to that hydrophobic nature, iron which can be removed from iron core to the outer side of the ferritin. Okay, and then whenever this leaves the Fe, it goes to the blood stream. Then it leaves to the blood stream. It leaves to blood stream. Okay, this is about what? The ferritin. We learned what is the ferritin. These are the iron storage protein which is present in the human, higher animal and the plant. These are stored in the liver, bone marrow, and also the spleen. Here, this contains the apoferritin molecule, which can be combined with 4000 atoms of the iron. These contain about 24 protein subunit. Each protein contains 175 amino acid, and the deficiency of this iron which causes the anemia. Next, ferritin structure. This ferritin which contains the iron core and the outer part, that is called as apoferritin. This iron core, where the iron are the store, here about 4000 irons which can be stored. Okay, and here they store in the form of Fe3 plus and FeOOH. Then it contains the 8 channel for addition of the ion into the ion core, and for the removal of the ion from the ion core, there are the 6 channels that are hydrophobic in nature, and here they lose the ion and goes to the bloodstream. This is about the ferritin. Next we are going to learn that is what the ferritin. These are transferrin. The transferrin are the ion transport protein. This is very important. This is the ion transport protein. It transport the Fe from what? The stomach to the, sorry, this is the bloodstream, not bloodstream, bloodstream. And here this transferrin has the ability or more binding affinity of the Fe3 plus. That means what? It binds only Fe3 plus, okay, not Fe2 plus, okay. It bind only what? Fe3 plus. Here this transferrin, which contains about 679 amino acids, okay. Let's we see the structure of and how this ion which can be transport and this ion and transport to the ferritin, okay. Here this is the structure of that. This is the ceruloplasm. At the pH in the plasma, the pH is 7.4. At this pH, what happened? These are the apoferritin. This is the Fe3 plus unit. Why? Because this transferrin which can be bind only what? The Fe3 plus. Then this Fe3 plus which can be bind to this ceruloplasm. Here this is the binding transferrin, where what happened? This is binded here. This is the hollow. This is the hollow apoferritin, where Fe3 plus is going to bind over here, okay. And then this, whenever this is bind to here, then it transfer to the cell membrane over here, and this is attached to this connection. Then after binding this get converted this to this form, okay. And then what happened? This is the acidified endoplasm. This goes to what? The endoplasm. First step is what? The attachment of Fe3 plus into this connector. This is called as a receptor. This receive the ion, that's why it is called as a receptor, okay. Then after attaching this into the receptor, then it is goes to the endoplasm, where the pH is about 5, which causes the release of Fe3 plus from the transferrin, okay. Here this is the transferrin. Here this is the apoferritin of apotransferrin. This apotransferrin, which is the hollow transferrin, that means this it doesn't contains the Fe3 plus. Then this whenever this is hollow or empty, that time this Fe3 plus which is banded to this hollow transferrin, then this is attached to this receptor. Whenever it's attached to this receptor, which is goes to the endoplasm, and whenever it goes to the endoplasm, then the pH of this endoplasm, it changes from 7.4 to the 5. At this pH, what happened? It causes to release the Fe3 plus. Here at this endoplasm, this releases this Fe3 plus from this transferrin, okay. After that, it goes to the ferritin, okay. Here there is a ferritin, where what happened? This Fe3 plus get converted to the Fe2 plus, okay. And then after releasing this Fe3 plus from this transferrin, then this transferrin is ready to capture the another Fe3 plus from the plasma membrane, okay. This is the circle for the transportation of the Fe from different side to the ferritin. This is the simple mechanism of the transferrin, okay. What happened here? This is the apotransferrin. This apotransferrin has the ability to bind only Fe3 plus. It binds this Fe3 plus and attached to the receptor, okay. At this position, the plasma having the pH 7.4. Whenever this attached to this transferrin, apotransferrin containing Fe attached to the receptor receive this Fe and enter into the endoplasm, where the pH of Fe is 5, and here this pH which is required for releasing the Fe3 plus from the transferrin. At this position, the transferrin which releases this Fe, and this Fe which is convert Fe3 plus to the Fe2 plus unit. Okay, and here this is this Fe2 plus which is goes to the Fe2 plus which is goes to the ferritin. This is goes to the ferritin, where it is what stored, or this Fe2 plus also transported to the biological reaction or the storage, that is where it is required as in the form of Fe2 plus or the Fet plus, which can be used in the biological reaction or for the storage of the Fe in the ferritin. And then this empty apotransferrin which is goes to the outer side, okay, for attachment of the another Fe3 plus. This is about what? The transferrin. Today we learn that is ferritin and the transferrin. Mostly here this transferrin which are divided into the two types. Transferrin which is divided into the two types. First, that is called as a ovatransferrin. And the second one, that is called as the lactoferrin. This ovatransferrin which is present in the ovum, okay, that means in our body, and here this lactoferrin which is present in the mother's milk. What is the function of this lactoferrin? This lactoferrin which is important, or this lactoferrin is the antibacterial agent. This is what? Antibacterial agent, and this is useful for to protect the infant. Infant, that means what? The small baby. It protect the infant from the several infection. Okay, here this transferrin divided into two types: ovatransferrin, which is present in the ovum, and another one is a lactoferrin which is present in the mother's milk. This is the antibacterial agent which is protect the infant, that is a small baby, from the several infection. This is about the ferritin and the transferrin. Thank you very much for watching this lecture. This is very important. Always ask in the examination. The questions will be asked like this: dash dash, it's the iron storage protein, that means what? Ferritin, and dash dash is the iron transporting protein, that is what? Transferrin. Okay, here the one more question will be asked, that is what? This ferritin which is present in what? The liver and the spleen. The deficiency of the iron which causes dash dash, which disease? Anemia disease. Okay, here it contains the ferritin contains the 8 channel. These are dash dash what? Hydrophilic. And it contains the 6 channel which are dash dash, which is what? The hydrophobic. What is the function of this 6 channel? Which is useful for the iron to leave from the core of the ferritin. And what is the function of 8 channel? This is useful for what? The entering of the iron into the iron core. Okay, this is about what? The MCQ which will be asked in your examination. Okay, so thank you for watching the lectures.